Hi everyone, my name is Jason Jiang, and today we'll be discussing the solutions to the 2012 AMC 8. Starting with problem 1. Rachel uses 3 pounds of meat to make 8 hamburgers for her family. How many pounds of meat does she need to make 24 hamburgers for a neighborhood picnic? So our ratio here is that 3 pounds of meat will be equal to 8 hamburgers, and we're asking how much meat can make 24 hamburgers. So the ratio between 8 and 24 is 1 to 3. So that means that the ratio between 3 and some unknown x must also be 1 to 3. And therefore x must be 9. Problem 2. In the country of East Westmore, statisticians estimate there is a baby born every 8 hours and a death every day. To the nearest 100, how many people are added to the population of East Westmore every year? So if there's a baby born every 8 hours, then in a 24-hour period, we would have 3 babies born. And we know that in every 24-hour period, there's also 1 death. So that's equivalent to minus 1. And that means that there's a net positive of 2 people per day. Each year has 365 or 366 days if it's a leap year, but we only need it to the nearest 100, so let's use 365, and we get 730 people, or 732 in a leap year. Either way, it's closest to 700. Problem 3. On February 13th, the Oshkosh Northwester listed the length of daylight as 10 hours 24 minutes. The sunrise was 6:57 a.m. and the sunset was 8:15 p.m. The length of daylight and sunrise were correct, but the sunset was wrong. When did the sun really set? So all we need to do here is take 6:57 a.m. and find what time is 10 hours and 24 minutes after that. We'll start by adding the 10 hours. So we add 10 hours, and we get that that's equal to 4:57 p.m. And now we just need to add 24 minutes, and we get 5:21 p.m. So that's option B. Problem 4. Peter's family ordered a 12-slice pizza for dinner. Peter ate 1 slice and shared another slice equally with his brother Paul. What fraction of the pizza did Peter eat? So now that the total number of slices is 12, and that he ate 1 plus 1/2 from the slice that he shared. So we're looking for 1.5 divided by 12, and once we simplify that, we get 1/8. Problem 5. In the diagram, all angles are right angles, and the lengths of the sides are given in centimeters. The diagram is not to scale, and we want to find x. So the key here is that the lengths down the right side are equal to the lengths down the left side as well. So on the right side here we have 1, 2, 1, and 6. And that adds up to 10. And we know that the left side must also add up to 10 then. So we have another 1, 1, 1, 2, and x. 1, 1, 1, 2, those all add up to 5, and therefore x must also be 5. Okay, that's problem 1 through 5. Let's keep going. Alright. So here we have problem 6. A rectangular photograph is placed in a frame that forms a border 2 inches wide on all sides of the photograph. The photograph measures 8 inches high and 10 inches wide, and we want to know the area of the border in square inches. So let's start by drawing the frame. Let's say it's 8 by 10. We know the border is 2 inches on all sides. So the photograph is 8 by 10, And if we add 2 to each side of the dimension, that's equivalent to adding 4 in total for each side. So what we end up is a 12 by 14 overall. The area of the border is just the area of the entire thing. Subtract the photograph, and that's going to be 12 times 14 minus 8 times 10. And that's the same thing as 168 minus 88, and that's, minus 80, 8 times 10 is 80, and that gives us 88 for the border. Problem 7. Isabella must take 4 100-point tests in her math class. Her goal is to achieve an average grade of 95 on the tests. Her first 2 tests were 97 and 91, and after seeing her score on the 3rd test, she realized she could still reach her goal. And we want to know the lowest possible score she could have made on the 3rd test. So in order to achieve an average grade of 95 on 4 tests, her total must be, at the minimum, 4 times 95, which would be equal to 380. And we know that her first 2 tests were 97 and 91, and we don't know her 3rd test yet, but we know the maximum possible score on the last test would be 100, and this would allow her to get the lowest possible score on the 3rd test and still make it. So all we need to do now is find this blank, and if we do the math, we get B, 92. Problem 8. A shop advertises everything is half price in today's sale. In addition, a coupon gives 20% on the sale prices. Using the coupon, the price today represents what percentage off the original price. So if everything is half price, then the price can be multiplied by 0.5, and similarly a 20% discount multiplies the price by 0.8. And if we multiply these, we get 0.4. So that means that we are 60% off, since there's 40% of the original price. Problem 9. The Fort Worth Zoo has a number of 2-legged birds and a number of 4-legged mammals. On a visit to the zoo, Margie counted 200 heads and 522 legs. How many of the animals were 2-legged birds? So let's use B to represent birds and M to represent mammals. We know that birds plus mammals is 200, since each only has 1 head. And we know that 2 times the number of birds, since birds have 2 legs, and 4 times the number of mammals, mammals have 4 legs, and that's going to be equal to 522. We just need to solve for B now. We first divide the second equation by 2, and that would give us B plus 2M equals 261. Now subtracting the first equation from this third one, we get that M equals 61, and substituting back into the first equation, we have B equals 139. Problem 10. How many 4-digit numbers greater than 1,000 are there that use the 4 digits of 2012? We know that the first digit can't be 0, but it can be 1. If the first digit is 1, our remaining 3 digits are 202. These can be arranged in 3 different ways, either 220, 202, or 022. So a 1 as a first digit gives us 3 possibilities. The next case would be having a 2 as a first digit, and that leaves us 012. And there are 6 possibilities here: 012, 021, 102, 120, 201, and 210. So there's our 6 possibilities, and our total is just 3 plus 6 is 9, since there are no other cases for the first digit. Next, the mean, median, and unique mode of the positive integers of 3, 4, 5, 6, 6, 7, x are all equal. What is the value of x? The key here is that we have a unique mode. If x were equal to 3, 4, 5, or 7, we would not have a unique mode. So x must be something else other than those 4 numbers. If x is greater than 6, then our median will be 6. And if x is less than 6, then our median would be 5. However, x would have to be less than 3 because all of these are positive integers. So we could try that case. Let's have x be equal to 2, for example. Then we have 2, 3, 4, 5, 6, 6, 7, and our middle is 5. However, this is not equal to our unique mode. And so that actually means that our unique mode has to be 6. And that means that x would have to be greater than or equal to 6. And in this case, it is in fact 6. Oh, sorry, it's not 6, right? So our median is 6. But what we actually need is our mean to also be 6. And since we have 7 numbers here, our total must be 7 times 6, which is 42. And if we add up all of these numbers here, the first 6 that are given, 3 plus 4 plus 5 plus 6 plus 6 plus 7, that's equal to 31, and that means that we need 11 more. So x is equal to 11. Problem 12. The units digit of 13 to the 2012th power. So we obviously don't want to be going through all 2012 powers, so let's just try to look for a pattern. 3 to the first power ends in 3, 3 squared ends in 9, 3 cubed ends in 7, 3 to the fourth ends in 1, 3 to the fifth ends in 3, and now we found a cycle here. Every 4 numbers we get back to 3. And we just want to look at the multiples of 4 now. Since 2012 is a multiple of 4, the units digit will be the same as that of 3 to the fourth. When 3 to the fourth ends in 1, it's 81, so our answer is 1. Problem 13. Jamara bought some pencils costing more than a penny each at the school bookstore and paid $1.43. Sharana bought some of the same pencils and paid $1.87. How many more pencils did Sharana buy than Jamara? So we need to do some prime factorization here. 143's prime factorization is 11 times 13, and 187 is 11 times 17. Their common factor is 11, and it's not going to be 1 because we know the pencils cost more than a penny. So the pencils cost 11 and they bought 13 and 17, so the difference is 4. In the Big N, a middle school football conference, each team plays every other team exactly once. If a total of 21 conference games were played during the 2012 season, how many teams were members of the Big N conference? So for n number of teams, they're going to play n minus 1 games, 1 against each other team, and that would be the total number of games, except for the fact that if Team A plays Team B, we've actually already counted that when we do Team B plays Team A. So we actually have to divide by 2 in order to not double count those. And we know that this has to be equal to 21, so we solve for n and get n equals 7. Next, the smallest number greater than 2 that leaves a remainder of 2 when divided by 3, 4, 5, or 6 lies between what numbers? So what we need is a number that's divisible by 3, 4, 5, and 6, and then we can add 2. So that's the equivalent of finding the least common multiple of these numbers, and that's going to be 60. So 60 plus 2 is 62, lies between 61 and 65. Problem 16, each of the digits 0 through 9 is used only once to make 2 5-digit numbers with the largest possible sum. We want to know which could be one of the numbers. So we want to have the largest numbers be in the largest place values. So 9 and 8 would be in the first place value, 7 and 6 in the next, 5 and 4, 3 and 2, and 1 and 0. But we can mix these up pairwise, so the 9 and the 8 could be flipped, 7 and 6 could be flipped, and so on. So we need to find one of the numbers where each place value is one of the 2 numbers. And the only one that satisfies that is 87431. Problem 17. A square with integer side length is cut into 10 squares, all of which have integer side length, and 8 of which have area 1, at least. We want to know the smallest possible value of the length of the side of the original square. So let's just go through these values then. If we have 3, then that has an area of 9, so it's not even possible to make 10 squares in the way that they're asking. If we try 4, this seems a little more promising. We have a way to break them down like so. And each of the 8 squares on the left is area 1, and the last 2 are area 4. And this works, so our answer is 4. Problem 18. What is the smallest positive integer that is neither prime nor square, and that has no prime factors less than 50? So with no prime factors less than 50, let's just go up from there. We have 53, and we can't be prime, so we need to find a second factor, but it can't be square, so we need a different factor than 53. So we keep going up, and we eventually find 59 as the next prime. And if we multiply those two, we get a 3,127. In a jar of red, green, and blue marbles, all but 6 are red, all but 8 are green, and all but 4 are blue. How many marbles are in the jar? So using R, G, and B, when all but 6 are red, that means that the blue plus green would be equal to 6. And when all but 8 are green, that means that the red plus blue is equal to 8. And finally, the red plus green is equal to 4. With these 3 equations, we can add them all up to get 2 times the red plus 2 times the green plus 2 times the blue equal to 18. And if we divide that by 2, we get red plus blue plus green, which here is the total number of marbles in the jar, what we're looking for. That's equal to 9. That's our solution. Problem 20. What is the correct ordering of the 3 numbers 5/19, 7/21, and 9/23 in increasing order? So the key here is that each of the numerators are 14 less than the denominator, and therefore we can write them as 1 minus 14/19, 1 minus 14/21, and 1 minus 14/23. Since we know that 1/23 is smaller than 1/21, and that's smaller than 1/19, we can just reverse engineer that and come up with B. Since 9/23 is only 14/23 away from 1, that makes it bigger than 5/19, which is 14/19 away. And we know that 1/19 is bigger, so it's further away. Problem 21. Marla has a large white cube that has an edge of 10 feet. She also has enough green paint to cover 300 square feet. She uses all the paint to create a white square centered on each face, surrounded by a green border. We want the area of one of the white squares in square feet. So with enough green paint to cover 300 square feet and 6 sides on a cube, that gives her 50 square feet of green paint per face. Each face has an area of 100 since it has a side length of 10. So then the total amount of area for the white would be 100 minus 50. And that's still 50. So problem 22. Let R be a set of 9 distinct integers. 6 of the elements are 2, 3, 4, 6, 9, and 14. We want the number of possible values for the median of R. So we're going to add 3 more values here. If they're all really small, A, B, C, let's say these are smaller than 2 even, then our median would be 3. However, if A, B, and C were really big, then our new median would be 9. And if we use numbers in between, then we can make anything in between 3 and 9. So all the possible values are the integers from 3 through 9, and there are 7 of those. Problem 23. An equilateral triangle and a regular hexagon have equal perimeters. If the area of the triangle is 4, what is the area of the hexagon? So let's draw a triangle and a hexagon. So we know that the area of the triangle is 4, and we know that they have equal perimeters. Since there are 3 sides on the triangle and 6 sides on the hexagon, we know that for the side length of the triangle, let's say that's 2x, then on the hexagon it would only be x. But we also know that the hexagon is made of 6 equilateral triangles. However, each of these equilateral triangles has half the side length, and therefore 1/4 the area of the triangle. And so with 6 triangles of area 1, our area is then going to be equal to 6. So let's clear all these drawings. So we know that our area is equal to 6. Problem 24. A circle of radius 2 is cut into 4 congruent arcs. The 4 arcs are joined to form the star figure shown, and we want the ratio of the area of the star figure to the area of the original circle. So what we can do here is draw a square around the circle, and these 4 arcs on the outside of the circle are precisely the arcs that you could see right here. And we know that the circle is radius 2, so the square has side length 4, which is the diameter. So the total is 16 for the square. Now the circle is radius 2, and the area of a circle is pi r squared, which means that the circle has an area of 4 pi. So we want the ratio of the star to the area of the original circle. The circle is 4 pi, and the star is 16 minus 4 pi. It's the square minus the circle here. And that's going to simplify to 4 minus pi over 4, and that's A. Okay, on to problem 25. A square with area 4 is inscribed inside a square with area 5, with one vertex of the smaller square on each side of the larger square. A vertex of the smaller square divides a side of the larger square into 2 segments, one of length A, the other of length B. What is the value of AB? So when our center square is area 4, then each of the side triangles must have area 1/4 in order for the large square to have area 5. Since the area is equal to the base times the height divided by 2, we know that the base times the height was equal to 1/2, and then when divided by 2 became 1/4. So our answer here is C. Alright, that's all the problems. So thank you everyone for watching. See you next time.